All right, so welcome to the deep dive on this unit. Um, so to summarize everything you've learned so far, I'm using the notation where I'm saying f of x, so it can be any function I'm talking about. And the things that we can do to transform it is we can add something to it inside of the function. We can add or subtract something from the end, and there could be something in front. And they all have different meanings. The c on the end, if it's at the end of everything and it's a positive, it's telling you to translate it up. And if it's negative, it's telling you to translate it down. Inside the function, this b, what does it mean if it's positive? If it's positive, it's telling you to go to the left because inside of the parentheses is opposite of what you think, which means if it's negative, it's telling you to go to the right. Assuming there's no negative in front of this a, what does the a tell you? The A is your vertical compression or stretch. Where it's going to either make it taller or shorter. So it's either a stretch, so I'm going to put S, or a C for compression. And if there were a negative in front, what would that tell you to do? If the A is negative, it means to reflect. And you're reflecting it over the vertex, but I'm not going to write that all out. I'm just going to say reflect. So those are all the different transformations inside of the equation. So these are the steps for graphing. So the quickest way to graph this, any of them, would be to first determine what that parent function is, whatever that f of x is, and what's the original shape for that graph. Then, since they all have a 0, 0, you're going to move the 0, 0 of the original based on your translations up, down, left, and right. So these ones over here, the B and the C. Then, from the vertex, you're going to go right one and up a amount. So in blue, I did up because it's actually down if it's being reflected, if this negative is in front. And the A is whatever number the vertical stretch or compression is, whatever this is. So if there's nothing there, then it's the invisible 1. So then it would be up 1. But whatever other number is there is how much you go up or down by. Step 4 is not for the square roots. Because there isn't a third point for them, but for the absolute values and quadratics, from the vertex, you're going to go left and up the a amount, but down if it's reflected. And then for cubits and cube roots, you're going to go left and down or up if it's reflected, whatever that a amount is. And step 5, once you're done with all of this, is to connect the dots with the correct parent function shape. So there's this example that we're going to do. It's -3 absolute value of x plus 1. So I said the parent function aloud, it's the absolute value. For step 1, determine the parent function, absolute value. What's the original shape? It's a V. So we're going to move the 0, 0 based on the translations. So 0, 0 is going to move. Is it going to go up or down? No, there's nothing at the end. Is it going to go left or right? Yep, it's going to be left 1. So I'm going to go left 1 and put a dot. Now for my next dot. Now for my next step, it says from the vertex that my new one, I'm going to go right 1 and up my a amount, or down if it's reflected. So it's going to be right 1, and is it going to go up or down? Down, because it's being reflected. And how many down? Down 3. 1, 2, 3. And then for step 4, this is an absolute value graph. So I'm going to go from my new vertex left 1 and up or down my A amount. So from my new vertex, I'm going to go left 1 and I'm going to go up or down? Down because of the reflection, and how many? Down 1, 2, 3, because the vertical compression slash stretch is 3. So that's the proper graph, because now I'm doing my last step of making the right shape. Sometimes they just want you to graph it and this will count. Sometimes they say list the transformations, which means you actually have to write them all down too. Even if they don't have this transformations, if the question says list them, make sure that you're writing them all down. So in this case, we have a reflection around the vertex, vertical, vertical. Is this a stretch or is it a compression? 3 is more than 1, which means it stretched it out by 3. And then a translation, left 1. That's the gist of what you've learned, everything so far. We skipped of the 7 parent functions I first taught you. I never made you practice translating a constant or a linear. So here's the thing about translating a constant. Let's say it's y equals 4. I add 1 to it, it will shift it up 1, but 4 plus 1 is 5, so it's just a new one at y equals 5. So we could move our line up and down, sure, but then once you combine them, you get a whole new equation. So basically, the problem with any of the other ones is if you go back to the original here, you can't go left or right if there's no x to add to. And then you can't reflect or have a vertical stretch or compression if there's no x to have a number in front of it. So if the only thing we have is this number at the end, this plus c, that's away from the x part, then all it's going to do is go up and down, a flat line that goes up and down. So then with linears take this general form of y equals mx plus b. So an example of this might be 3x minus 5. And when you were originally taught to graph something like this in year 1, what they would have told you to do is they would have said, okay, the b at the end, b is your y-intercept, or your starting amount. So at -5 on the y-axis, I go down 5 and I put a dot. And that's how you'd start with graphing this from year 1. Then step 2 is m is your slope, which is how much you're growing by. After one whole time has passed. So for 3x, that means I'm going up 3 after one time. And so that's my next dot. And I would have put a point there and connected them. Well, it's almost the same thing as if you use transformations, because this is the original. And your transformations are telling you to go shift down 5. So you shift 0, 0, down 5, down here at -5. Then this one originally goes right 1, up 1. But instead, I'm from -5, now I'm going to go right 1 and up 3 and put my new dot. So by using my translating down and my vertical stretch of 3, I end up with the same graph. They're both equally as fast, no matter what you think of it. It's just that you go down 5 and then up 3 over 1. Whether you think of it as starting amount and slope, or if you think of it as translating down 5 and having a growth of an A of 3, where you go over 1 up 3 instead of just up 1. So the next thing to talk about on a slightly deeper level is if you had to do any reflections over the x and y axis. Because right now I've taught you reflection over the vertex. So reflection over the vertex, like let's say this is our graph right here. And if I just want to flip it down, it's this one where there's just a negative in front of the function. Like right in front of that parentheses, there that negative goes. And it flips it over like that. So whenever the negative is just right in front of the function, this is what reflects over the vertex. Because this vertex doesn't change, it's just the other points go right and down and stuff at instead of right and up. But it's not the only way I could reflect. So this is a negative around the entire equation. So it's not just in front of the beginning part like this one is. It's like it took the entire thing and put it in parentheses. Like this entire equation got parentheses on the outside. And then a negatives in front of all of it. And so that changes it because the vertex is not at the same place anymore. What this one does, it's called reflecting over the x-axis because this is x side to side. And you see the x-intercepts are on the x-axis, so they don't move. But the vertex is down 3, so the new vertex goes up 3. And then the shape gets flipped in the other direction. So it's the x-axis, that's the line that it's flipping around. Versus this one, and where it's the vertex is like the line that it's flipping around. So the whole thing just flips down, versus this one, it kind of flips up into itself and goes up there. So with the negative in front of the entire equation, and it's a reflect over the x-axis. Versus this negative, and this guy is only in front of the x. So if you look how it's different, the vertex is in front of the function, the x squared parentheses, but not the -4. For over the x-axis, the -4 is also in a parentheses with all of it, and there's a negative in front. Versus this one, the negative only goes in front of the x. So when it's right in front of the x, see how it flipped over the y-axis? This up and down line right here? It's like this whole slate shape got picked up and flipped over. And so like this 5, 5, it's on the y-axis, so it's at the same place for both. But then here, this one's 1 away to the left, so this one goes 1 away to the right. This one's 5 away to the left, so this one goes 5 away to the right. The vertex from the y-axis is 3 to the left, so the new one goes 3 to the right. So it's the up and down y-axis line that it gets flipped over or reflected over. So this makes it reflect over the y-axis. However, this is the only one, the one I need you practice, is the only one that shows up on the test this year. So another way they can make this harder is sometimes they aren't going to ask you to transform things from the parent function per se. Like here, they're saying how did f of x? F of x, this red line, is not a parent function. It's definitely been transformed. But they want to take this and somehow transform it into g of x somehow. So if I start here and I'm trying to take this and turn it into this g of x, so if I just start working through my transformations, the easiest thing to do is to start with the vertex. And the vertex is going down 2 and then right 1, 2, 3 to get to this guy right here, this blue g of x vertex. So I would be going down 2 and right 3. So I take f of x and I go down 2, and that's at the end, and then right 3 is a -3 inside. So far this is good. In order to take f of x and turn it into g of x, they're saying we're going down 2 and right 3, which is correct so far. They're also saying it's -1/2 in front. Well, the negative means what? Negative means to reflect, and they are being reflected right now. It does get flipped over. And the half, for the f of x, when I go over 1, it's down 2. Well, half of 2 is 1, and it's definitely now going over 1, up only 1. So it is half of what this was. So A is correct. So the reason why this is a trick question when you see it on the SAT or something is because in the next one switches the f of x and the g of x. So they're trying to confuse you. But it's not like we take g and go down 2 and write 3, because from g, if I went down 2 and write 3, I'd be all the way over here by the 7. And that's not what's going on. Also, I don't want to take g and turn it into f, because this is saying f equals all this stuff happening to g. But this is saying f turning into g. So it's important because they could have flipped it. And if they flipped it, then D would have been the answer. Because in order to take G and then get the other one, you're going to go left 3, then up 2, so the plus 2 at the end. And it's still negative half, because it still gets, oh, it's not negative half, because it's not half of G. It would have to say negative 2 in order for G to be right. Because from G to F, we times it by 2 because we double it. But since the question was like this, all of these were just to trick you. But to go from the F to the G, this is the stuff we had to do. But note that this is different than if they asked you for the equation, because that's something else they can do. They can take any graph now almost and say, okay, so what's the equation? Because right now, if I give you the equation, you should be able to graph it. But reversing it is pretty fast, and it's expected of you at this point. So this is how it works. So this one says, what's the equation of f of x? So we're looking at this red line. Well, first of all, you start with what family is it? F of x is in what family? Well, this is the square root graph. For f of x, though it's not just the square root, because the vertex moved to the right 1, and so how would I write to the right 1? It would be minus 1 under the square root with the x, because it needs to be in the function with it. But I'm not just going right 1, I'm also going up 1, 2, 3, 4. So how do I write up 4? By writing plus 4 at the end of the equation. So I'm still not done, because just going right 1 and up 4 would make it still you kind of up. It would go over 1, up 1. So to get it to flip over, how do I do that in an equation? I have to put the negative in front. That flips it over. But flipping it over, which should have made it go over 1, down 1, and it's not down just 1. It went down a whole second 1 to get that dot right there. So that means it wasn't just negative, it was negative 2, because it went down 2 from the vertex, right? 1, down 2. And so now I have the equation of this graph, because I got its translations, its reflection, and its horizontal/vertical compression. They could also ask you for the equation of g of x. So g of x equals, it's the square root graph. It definitely isn't at the 0, 0. It went right 1, 2, 3, 4. And then, so how do I write right 4 in an equation? By putting minus 4 under the square root with the x. So it went to the right 4. It also went up 2. And so how do I write up 2? By putting the plus 2 at the end of the equation. All right, now I have to ask myself, is g of x being reflected? No, it's not, so there's no negative in front. And it's a vertical stretch or compression. It's going over 1, up 1. So is there a vertical stretch or compression? Technically not, because 1 in front is the normal one. You don't have to write 1 if it's 1, because it's the invisible 1. So then that would be the equation of g of x if you were asked to get the equation. So this is it on the part about transformations and the deep dive and how you can take it further. The 4 questions on the test about transformations, number 1 through 4, they're a lot easier than what we just did on this deep dive. However, they are also the tiniest part of this test because they really, really, really care about the quadratics units. And there was a reason why we spent 2 whole units on quadratics. It shows up again in year 3. They really need you to prove mastery on this stuff in order to graduate. So they put it on a lot of the test. So number 5, 6, and 7 is all about unit 6, and that's most of the points. Like most of the tests, because like each question for 5, 6, and 7 have like 5 or 6 parts. It's a lot of work. 1 through 4 is going to be super fast and easy and about what you've learned in this unit. But then the rest of the test, most of the points, are about the things you learned in unit 5 and 6. So I'm going to end the deep dive for transformations at this point. However, there's going to be a second video about the test itself and about the stuff from unit 6 that's on the test that you need to remember in order to do well on the test. Which is why this unit has 2 different videos in it. One for the deep dive and one in order to review the stuff from unit 5 and 6 that's going to show up a lot on this test.